For part C, we're asked, does f of negative 2 equal f of 2? Well, from the given graph, we've seen that we're not able to really get a good estimate for f of 2, and similarly, we wouldn't be able to get a good estimate for f of negative 2. But let's go ahead and use the graph that we've created on our calculator to help us. We see that f of 2 is equal to negative 16. What is f of negative 2? Well, let's enter negative 2 for x. And we see that the corresponding y value is negative 16. We could also create a table of values. If we go to Table Set, second window, and change the independent variable to ask, then we can go to Table, which is second graph, and we can enter negative 2 for x, and then 2 for x. And we see that both f of negative 2 and f of 2 are the same. Let's see if we can verify that regardless of whether n is equal to 4 or not. Let's just use our function. Let's first of all find f of negative 2. We substitute negative 2 for x. We get k times negative 2 to the n. But we know that negative 2 to the n is the same as negative 1 to the n times 2 to the n. Now we're guessing that n is 4, but it might be 6 or 8. The key thing is that it's even. If we raise negative 1 to an even power, that means that we're multiplying negative 1 by itself an even number of times. And negative 1 times negative 1 is equal to positive 1. So when we multiply negative 1 by itself an even number of times, we just get the number 1. Well, 1 times anything is itself, and so this expression just simplifies to k times 2 to the n. Next, let's find f of 2. We go back to our original function and substitute 2 for x, and we get k times 2 to the n. Well, that's exactly what we got for f of negative 2. And so we can clearly see that yes, f of negative 2 is equal to f of 2. For part D, we're asked, is f of negative x equal to f of x? Well, we've seen that f of negative 2 is equal to f of 2. Let's just check a few more values. Does f of negative 3 equal f of 3? So let's enter negative 3 and 3. And we see that both have a value of negative 81. Let's try negative 4 and 4. We see that both of those have a value of negative 256. So it appears that their answer is yes, that f of minus x is equal to f of x. But let's see if we can verify it symbolically. We already know that f of x is equal to k times x to the n. Let's see if we can simplify f of minus x to get that. To find f of minus x, we substitute minus x for each x in the formula. We get k times minus x to the n. But minus x is the same as negative 1 times x. So minus x to the n is negative 1 to the n times x to the n. But we know that n is even, and when we raise negative 1 to an even power, we get the number 1. When we multiply these three factors together, we get k times x to the n. Well, kx to the n, that is our original function. That is equal to f of x. So the answer to our question is yes, f of minus x is equal to f of x. It is interesting to note that when f of minus x is equal to f of x, the graph of the function is symmetrical about the y-axis. In other words, when we fold the graph along the y-axis, both sides of the function coincide with one another. So that's how we could have answered the question graphically. For part E, we're asked, as x goes to infinity, f of x goes to what? Well, what we want to observe on our graph is that as x goes to infinity, as we go out to the right, the function values are decreasing. And not only are they decreasing, they're decreasing without boundary. That indicates that f of x is going to minus infinity. To reinforce that, let's look at a table of values. We want to determine what happens as x goes to infinity. So let's start off with x is equal to 10. And then we'll let x increase without boundaries. So next we might try 100. And then 1,000. And then 10,000. Notice that our corresponding y values are negative 10,000, negative 1 times 10 to the 8th power, negative 1 times 10 to the 12th power, negative 1 times 10 to the 16th power. The absolute value of these numbers is getting bigger and bigger and bigger, but all the values are negative. So that indicates that these values are decreasing without boundary. So as x goes to positive infinity, f of x goes to minus infinity. What happens as x goes to minus infinity? To answer this question graphically, we look at the graph and we ask ourselves, what happens to the y values as we move further and further to the left? Well, we see that the function values are decreasing without boundary. So that tells us that as x goes to minus infinity, f of x also goes to minus infinity. To explore this numerically on the calculator, we could change these x values from positive to negative. When we change the x values from positive to negative, we see that the corresponding y values are the same. Remember in part D, we show that f of minus x is equal to f of x. So the exact same thing happens. As x decreases without boundary, the y values decrease without boundary. As x goes to minus infinity, f of x goes to minus infinity.